Dear children, you are aware that we are learning about the topic force and pressure. And today we will be learning about pressure. So let us try to understand what is meant by pressure. The force acting on a unit area of a surface is called pressure. What is pressure? The force acting on unit area of a surface is called pressure. Pressure equals to force per unit area. And the SI unit of pressure is Pascal. And SI unit of force is Newton. And area is measured in meter square. So therefore 1 Pascal equals to Newton by meter square, or simply we can write 1 Pascal equals to Newton meter square. So this is the formula for finding pressure or force or area we can find out. Now the pressure is inversely proportional to the area in which the force is applied. The pressure is inversely proportional. Now pressure increases with decrease in area. If area is less, pressure will be more, and if area is more, pressure will be less. So winds during storms or cyclones blow, the rooftop also, you might have seen. How it is happening, children? It is due to pressure. And you might have seen that the wheels of heavy vehicles such as trucks, etc. have very broad wheels as compared to scooter or bicycle, etc. Why so, children? This is because if heavy vehicles are there, if the area is more, the pressure on the road will be less. Now, let us try to understand more about pressure with the help of some activity. So, our activity is pushing a nail into a wooden plank. How to do this? We need a wooden plank and a nail. So you know that nail has one head region and the one pointed region. Now, our first step is we should try to push a nail into a wooden plank by its head, this area. Will it go, children? Do you think it will go inside the wall or the wooden plank? No, it will not go. So, next step is now push it by its pointed end, this end. What do you think? Will it go? Yes. Just now we have seen that if area is less, pressure will be more and it makes our work easier. So, this time it is being nailed. And our conclusion is the area over which force is applied plays a very important role or key role in making our task easier. So the smaller the area, the larger is the pressure on a surface for the same force. So it depends on the area how much pressure to be applied. Dear children, now let us see some more examples to show relation between area and pressure. First one is tools used for cutting have sharp edges. Dear children, you might have seen that your mother uses knife which is having very sharp edges to cut the vegetables. If it is having blunt end, will it cut the vegetable? No, it will not. So it should be having less area so that work can be done faster. Similarly, shoulder bags. That is the bags, school bags have, you might have seen, it is having a broad strap instead of thin straps, because broad straps means area is more, you will feel less pressure children. So you should wear bags with broad straps, not with narrow or the smaller straps. Next, you might have seen porters. What the porters will do? While carrying heavy load, they place one piece of cloth on their leg. What happens due to this? It increases increases the surface area on their head and they feel less pressure while carrying the heavy load. Dear children, now let us learn about pressure exerted by liquids and gases. And today we will be learning about liquid pressure. So let us start this with the help of an activity. So our activity is pressure exerted by water at the bottom of the container depends on the height of its column. So how much is the height of the column, water column? Pressure at the depth will be more. So let us see how to do. The materials required are any transparent glass tube or plastic pipe. The length of the pipe should be 15 centimeter. This one 15 centimeter length and the diameter should be 5 to 7 centimeter. Then thin sheet of good quality rubber or any rubber balloon. Here for tying here at the bottom we can take any good quality rubber sheet. Let us see how to do the experiment. So the method is, first step, stretch the rubber sheet tightly over one end of the pipe. Here, this is one end, this is another end. The lower end here, stretching the rubber sheet and tying it very tightly. Second one is, hold the pipe in vertical position. Like this, we have to hold the pipe in vertical position. Now, next step is pour water in the tube. So we have to start pouring water from the up portion in the tube. So what we see? We see that this portion, rubber sheet portion bulges out, it starts bulging. Why it happens, children? This is due to water pressure or liquid pressure. Now let us see next what happens. If we pour more water in the pipe, here earlier it was up to here only. Now if we pour more water in the pipe and observe the bulge in the rubber sheet and height of the water column in the pipe, what do we observe? We see that here you see children, more water is poured and we are holding it in vertical position. Here you see the bulge of the rubber sheet. So we observe that the height of the water column increases. As more water we are pouring, height of the water column increases and the bulge in the rubber sheet also increases. So with this we can prove that liquid also exerts pressure. So I hope you understood about this activity. So the name of the activity was pressure exerted by water at the bottom of the container depends on the height of its column. How much it will expand depends on how much water we are pouring into the pipe. Dear children, now let us try to understand more about liquid pressure with the help of one more activity, that is liquid exerts pressure on walls of the container. Here we have a container, we have liquid. Let us see how it takes place. So what we have to do, what is the method for that? We have to take a plastic bottle. We have to take a plastic bottle. Then fix a cylindrical glass tube a few centimeters long near its bottom. We have to fix this glass tube near the bottom. Then how to do that? How to make hole in this plastic bottle? We have to heat one end of the cylindrical glass tube and quickly insert it near the bottom of the bottle. So while heating, you take care that don't heat it much and then try to insert in the plastic bottle near the bottom. You have to see any leakage with molten wax. Wax you melt and try to seal this area. Water may leak out, so try to seal it. Next, cover the mouth of the glass tube with a thin rubber sheet. Here, this is the rubber sheet. You have to cover it. And this is the plastic bottle. Now let us see what happens. Now fill the bottle up to the half with water. Again, you have to pour water in this up to half. You have to fill it. the sheet. Here. Earlier it was not bulging. After filling the water in the bottle, it starts bulging. So what do we conclude from this experiment, children? This activity indicates that the water exerts pressure on the sides of the container. So this was experiment based on liquid pressure, based on one of the properties of liquid pressure. I hope you understood about this experiment, children. Thank you. Dear children, now let us see one more property of liquid with the help of an experiment. The property is liquid exerts pressure at the same depth. So what are the materials required for this? We need an empty plastic bottle, here you can see, and water to be filled and for the activity to be done. Then let us see how to do this experiment. So first we have to take an empty plastic bottle and drill 4 holes all around near the bottom of the bottle. How many holes we have to drill? 4 holes. Where we have to do? Near the bottom of the bottle. Like here 1, 2, 3 and one is behind, which is not visible to us. And all the holes should be at the same height from the bottom. It should not be up and down. It should be on the same height. Next, fill the bottle with water. What we have to do next? We have to fill the bottle with water. Now, after filling this, what do we observe? We observe that different streams of water comes out of the holes and falls at the same distance from the bottle. Once again, what did we observe? Different streams of water comes out of the holes and falls at the same distance from the bottle. So what do we conclude from this experiment, children? We conclude that liquids exert equal pressure at the same depth. Once again, we conclude that liquids exert equal pressure at the same depth. Here you can see the figure for reference and you can do this activity. Now dear children, I hope you understood all the properties of liquid pressure. Thank you. Dear children, now let us see pressure exerted by gases. So do you think so? Gases also exert pressure? Yes, of course, gases also exert pressure. Let us take for example a balloon and try to inflate it. That means blow air into the balloon. Here I have shown the picture, 3 inflated balloons are there. Then, if we tie it very nicely, air will not escape. But if it is loose, what happens? Air will escape through the mouth of the balloon. So we can say that air exerts pressure. Now next let us see if there are balloons with holes in it. Will it be inflated, children? No, because air comes out of the holes. So air exerts pressure on the sides of the balloon also. Now let us see third one. A puncture in bicycle tube. Not only bicycle, it can be any puncture in any of the vehicle's tube. So what happens? You are unable to ride or drive because air has come out from the tube. So for all these things, let us see what is the reason. Air exerts pressure on the inner walls of an inflated balloon, in this case, or a tube. So if it is having any puncture or hole, then it will not work. So what do we conclude, children? Gases exert pressure on the walls of their containers. Wherever the gases are present, they exert pressure on the walls of their container. So dear children, this was all about liquid and gaseous pressure. I hope you understood. Try to do some activities related to this topic. Thank you, children.